The often used analogy to explain the domain name system is that it serves as the phone book for the Internet by translating human-friendly computer host names into IP addresses. Simply, DNS is a directory of names that match with IP addresses. As you may know, each device connected to the Internet has a unique IP address which other machines use to find the device. DNS servers eliminate the need for humans to memorize IP addresses, such as 212.80.75.134. Think about the websites you visit every day, Google and YouTube, Facebook, Twitter, etc. Without DNS, we would have to reach these sites by using their IP addresses instead of their names. I think remembering the names is so much easier than remembering the strange numbers. But it's still possible to reach the computer with that strange number string as well. Now, DNS deserves to have far more time spent on it. It could be a whole course in and of itself. But I just want to explain it simply without going too deep. So when you enter the URL, such as www.google.com, into the web browser, the request is not directly sent to the Google servers. Instead, the request goes to the DNS server that uses a lookup table to determine the IP address of the website that is being requested. Then it forwards this information to the proper servers and returns the information requested to your specific browser. DNS server is a computer server which contains a database of public IP addresses and their associated host names. It translates those common names to IP addresses as requested. DNS servers run special software and communicate with each other using special protocols. DNS is a client-server network communication system. DNS clients send their requests to and receive the responses from DNS servers. The requests containing the name and resulting in an IP address being returned from the server are called forward DNS lookups. The requests containing IP addresses and resulting in the names are called the reverse DNS lookups. The DNS directory that matches name to number isn't located all in one place. Pretty much like the Internet itself, the directory is distributed around the world, stored on domain name servers that all communicate with each other on a very regular basis to provide updates as well as redundancies. With more than 332 million domain names listed by the end of 2017, a single directory would be very large indeed. So when you type mail.google.com into your browser sends a query over the Internet to find the website. It's a query seeking to match the domain name with its corresponding IP address. So let's follow the path of this question over the Internet infrastructure. The first server your query interacts with is the DNS resolver, which can be operated by your ISP, Internet Service Provider. A resolver is basically responsible for initiating and sequencing the queries that ultimately lead to a full resolution. Domain name resolvers determine the domain name servers responsible for the domain name in question by a sequence of queries, starting with the rightmost, in other words, top-level domain label. Assuming the resolver has no cached records to accelerate the process, which is the worst-case scenario, the resolution process starts with a query to one of the root servers. The root servers are running all over the world, and each one knows DNS information about top-level domains, or TLD, such as .com. So to begin answering your query, the resolver asks a root server for DNS information about .com. So there are 13 sets of root servers in more than 300 locations around the world. Each TLD DNS name server stores the address information for second-level domains within the top-level domain, .com in our example. The second-level domain is google.com. When your query reaches the TLD server, The TLD server answers with the IP address of the domain's name server, which will provide the next piece of the puzzle. So this is the final step of address resolution. The recursive resolver sends the query to the domain's name server. This DNS server knows the IP address for the full domain, mail.google.com, and that answer is returned to the recursive resolver. Now that the recursive resolver knows the IP address for the domain name in your query, the recursive resolver tells the browser what the IP address is. So finally, your browser can send a request to the website to retrieve the website's content using the IP address it just learned. This whole process might seem, well, complicated. It certainly sounds it to talk it out, but really takes very little time at all.